In this exercise, you will learn how to service electric geyser. Close the input water supply valve of the geyser. Dismantle all parts of the geyser. The parts of the geyser are as shown. Check the continuity of each core of the power cable using multimeter. Check the insulation resistance between the three cores of the cable. The measure should show good insulation value. If the insulation is found weak, change the power cable. Using the measure, check the insulation resistance between the terminal and the body of the geyser. Check the continuity of the heating element with the multimeter. Any discontinuity of the heating element indicates its failure. Replace the heating element. Assume that the coil is okay. Remove the scale formation from the outer copper shell of the heating element and clean with a sandpaper. Assemble all parts of the electric geyser. Fill up the geyser with water. Switch on the power supply to the geyser. Adjust the thermostat to the desired value, say 60 degrees centigrade, and wait for reasonable time, say 1 hour. Check the temperature of the outlet water with a thermometer. If the temperature is at 60 degrees centigrade, then the thermostat is working fine. If the outlet water temperature is lower or higher than the set value of the thermostat, replace the thermostat. And repeat the temperature check. You have learned how to service an electric geyser. In this media, you will learn about the working of washing machine dryer. Cloth dryer is a mechanism which is used to remove moisture from the wet cloth after washing it. The important components of a cloth dryer are shown here. The keys in the control panel are used for starting, temperature varying, timer setting, and mode selection purposes. Tumble or drum is a rotating cylinder which is used to carry the laundry load. The blower is coupled with a drive motor. It is used to circulate the air through the drum. Before entering into the drum, the air is heated by heating elements. Thermostats, in combination with timer circuit logic, controls the drum operation and the air temperature. Assume the wet clothes are placed into the drum. When the motor starts running, it rotates the drum and blower. The blower blows the air from the drum to exhaust duct. So, the atmospheric air enters into the drum through the inlet duct and heating elements. The heated air is passed into the drum. Here, the hot air absorbs moisture from the wet clothes and converts into steam. The blower fan exhausts this steam outside the building through the exhaust duct. For safety purpose, generally 2 thermostat temperature sensors are used to prevent overheating. The first thermostat is located on exhaust duct close to the blower fan. It senses the exhausting air temperature. If temperature increases beyond the preset value, the thermostat cuts off the power supply and shuts down the dryer. The second thermostat is located close to the heating coils. If air flows through the drum and exhaust duct is cut off due to any reason, The air near to the heating elements will heat up quickly. If the air temperature increases beyond the preset value, the thermostat cuts off the power supply and shuts down the dryer. Now you have learned about the working of washing machine dryer. In this media, you will learn about the working of vacuum cleaner. The components used in vacuum cleaner are inlet port, exhaust port, flexible hose, inlet attachments, pipe, power cord, power switch, motor, fan, and dust bag. In vacuum cleaner, the fan is coupled to an electric motor. The fan has angled blades which are similar to the propeller blades in an aeroplane. The dust bag can be fixed anywhere between the intake port and the exhaust port. Plug the power cord to the mains supply points. Put on the power switch in vacuum cleaner. The motor rotates inside the vacuum cleaner. The fan, coupled with motor, also rotates. As the fan rotates, it creates a partial vacuum area behind the fan. The air pressure behind the fan is lower than the air pressure in the atmosphere. This results in suction effect. As long as the fan rotates, the atmospheric air flows into the vacuum cleaner through intake port. The air entering the vacuum cleaner will return to the atmosphere through the exhaust port. This moving air collects the dust particles by the basic principle called friction. If the moving air rubs against any dust particles, and this air is high enough to suck the dust particles, then the air carries the dust into the vacuum cleaner. The dust in the inlet air is filtered in the dust bag before it flows out of the vacuum cleaner through the exhaust port. The dust bag is made up of porous woven material. The fine holes in the dust bag will allow the air to pass through, but it won't allow the dust to pass through it. Thus, when the air enters into the vacuum cleaner, it flows out through the exhaust port, but the dust particles are collected in the bag inside the vacuum cleaner. There are different attachments to be fixed at the inlet port to use the vacuum cleaner for specified cleaning jobs. The attachment is connected to the inlet port using flexible hose and pipe. Thus, you have learned about the working of vacuum cleaner. In this media, you will learn about the working of duct-type kitchen hood. It is wall-mounted directly above the cooking surface. It consists of a stainless steel hood, blower motor, duct, heat sensor, and halogen light. The duct is extended to outside wall with an outlet orifice. There are 3 control switches in the control panel. Speed control switch controls speed of the blower. Delay timer switch controls the exhaust time according to the blower speed. Dimmer switch controls the illumination of halogen lights. Switch on the hood before starting cooking or deep frying. It enables the air circulation in the room. As the fan starts rotating, it collects the air surrounding the cooking area by the blower. Air passes through the duct and vents outside the kitchen. The heat sensor senses the excessive heat of cooking area. If blower is running at low speed, it automatically increases the blower speed. When temperature drops to normal value, blower will return to its normal speed. Thus, you have learned about the working of duct-type kitchen hood.